Very good morning. Hey all, how is everyone? Do let me know. Am I audible to all of you? Hey all students, welcome to all of you. Namaskaram. Very good morning. Warm welcome to all of you to yours Unacademy NEET English channel. So kids, am I perfectly audible as well as visible to all of you? I can see yes in the chat section. Let me go to the chat section. I can see very clearly Aruna Kumari ji is there, Khushbu is there, Shruti is there, Uma is there. Welcome, Vanakam, Suswagatam, Sasrikal, Namaskaram, Vanakkam. So today we are going to deal with the really best awesome lecture of this chemistry, and today I would like to give you the tricks along with the concept plus questions so that perfectly audible. How is the Josh? Kids, do let me know how is the Josh. I want to see the Josh should be very high, up. So kids, Suswagatam, I can see Unboxing Brothers. Wow, hearts, Unboxing Brothers. Right, Shanti Vishaleji, and how to manage all subjects. That I will let you know in the video, that recorded one. And Cherry Baby Ji, wow, Cherry Baby Ji is there, very high. That's really awesome. That's really awesome. I can see Shanti Vishaleji, Vanakkam. So, lot of students from South, and this channel is mainly for you people only because it's your channel. And hit the like buttons. What's the kids? What's going on? I can't see that the likes are getting increased. Kids, do remember what I'm saying. This is your channel. So I should not ask for the likes. It's your channel. That means likes automatically they should get increased. I want to see everyone hit the like buttons. Yeah, South kids, really awesome. So what I can see, how many likes are there? One, randa, mule, nale, anche, are, ere, ate, pad, padvanda, padaranda, padmule, padnale, pad anche, pad are, pad ere, pad ette, irubad, only irubad. So, suswagatam. Wow. So kids, so let's start without any delay. We are going to start with this lecture, and if you're new to this channel, don't forget to subscribe it, okay? And hit the like buttons, everyone. So what I can see, everyone still, Sujata S. So she's writing, wow sir, you speak Tamil well. Thank you from the entire core of my heart. Nadri ji is, so thank you for talking Tamil. Yeah, welcome. So everyone, Engeva to this, and those who thinks that isomerism pedikaradu customer, no, it's romba sulubham. So let's start. This is your HSP group. A brief introduction of HSP group. I did my MTech in 2004. Then you can say 1999 I was MSc gold medalist. This is just for new students. If anyone is new, so I'm going to tell you, in 99 I did my MSc in chemistry and I was the gold medalist. After that GRF qualified, GATE qualified, and then I did my MTech in 2004, and I have been teaching. Now you must be thinking, how 23 plus years? Just after MSc I started my teaching. So I have been teaching for the last 23 plus years and produced number of top 10 ranks along with the mass selections. So kids, without any delay, let's start. Like, share and subscribe. Oh, I can see so many hearts from Unboxing Brothers. Wow, Misbah, yeah. Okay, Cherry Baby ji, no problem. At least you know 2 languages. Now, kids, this I taught you yesterday. Do you remember? Double bond equivalent. Let me write down over here. yesterday I taught you double bond equivalent. Do you remember? Double bond equivalent. This I taught you yesterday. Now kids, one question based on double bond equivalent is over here. First, let me know what's the answer of this question. I want to see yesterday's homework has been done by each and everyone. If yes, so everyone do let me know what's the answer. Yesterday only I have told you double bond equivalent. If you are not seen double bond equivalent, then go and see to it, not right now after this lecture. But let me know what's the answer. It's B. Some are saying B. Mohammed Yahaji is saying B. Kids, do let me know everyone. I want to see. Now check it out. What I've told you from the structural formula how to find out double bond equivalent. That is number of rings plus number of pi bonds. So kids, do let me know how many rings and how many pi bonds are there. 1, 2, 2 rings. There are 2 rings, total 2 rings. And how many pi bonds? See, 1, 2, 3, 4, 5, 6. And if you write CHO, the CHO is like this. So 7, and cyanide is like this. C triple bond N. You can see cyanide. So 8, 9. 9. 2 plus 9, how much is it is coming? This is going to be 11. So yes, I can see 11 is the correct answer, kids. If your answer is right, do let me know in the chat section that yes, I want to see thumbs up. Your answer is right. If your answer gone wrong, do let me know by thumbs down, everyone. So now today, number of questions are there, but before teaching this question, how to find out, because we don't know metamerism, we don't know functional isomerism. So before this, let me tell you one by one each and everything, kids. Then I will deal with this question. Then I'm going to deal with that question. So first of all, I'm going to deal with, kids. First of all, I'm going to deal with ring chain isomerism. Everyone ready? Is everyone ready? Ring chain isomerism. Ring chain isomerism. So what is required for ring chain isomerism? One form of isomer must be cyclic. Cyclic. Do remember? One form of isomer must be cyclic, and another form must be acyclic. So do remember, everyone, if one form is cyclic and another form is acyclic, then we will say what relationship they are going to hold. Definitely they will be known as ring chain isomers. They will be known as ring chain isomers. Now let me explain with the help of one example. See to it, everyone. If I consider C4H8, so one form I am going to write like this, C4H8. This is, let us suppose, X form, and another form I am going to write like this, CH2 double bond CH, CH2, CH3. What do you say, kids? This form is cyclic and this is acyclic. You can see very clearly this is being cyclic and this is being acyclic. Now, if I say what is the relationship in between these two, one is being cyclic, another one is being acyclic, and both the molecular formula is C4H8. Both molecular formula is same, but one form is being cyclic, another form acyclic. So they are ring chain isomers. Ring chain isomers. And kids, do remember one thing. This compound is being saturated. this compound is being saturated because it is not having any pi bond, but this compound is unsaturated. So do remember one thing very clearly, that all ring chain isomers are always functional isomers. All ring chain isomers are always functional isomers. What I'm saying? All ring chain isomers are always what? Always functional isomers. Do remember this point. Now, if all ring chain isomers are always functional isomers, then why we are saying they are RCI? So this question is the $1 million question. Now see to it, everyone. Let me tell you, one day I have told you RT, FM, CP. So follow this rule. You will always get the correct answer. This is the preference order. Preference order of what? When any compound is following more than one type of structural isomerism. Always remember, if there is more than one type of structural isomerism, then the preference order is. Now, it's very tough to remember this preference order. So what to do? Now see, RT means you can say right. Right is famous position. Let me give you the code. Trick is, what is the trick? Trick is right. Let me write down right. Right is famous position. How is the trick? Right is always right. Right is always right. It's never wrong. Right is RT for right. Right is famous, FMC, famous. You can say famous, and position isomerism. Position. So kids, will you remember it? Right is famous position. Right is famous position. Can you keep it in your brain? Just do let me know. Are you able to get it? Because no need to do again and again revision. Always follow the thing. Always try to keep the thing in your brain. That the photographic memory. Because if you are going to revise again and again, you won't be able to revise the whole thing. There will be lag. Kids, repeat it always. Everyone write down. So ring chain isomerism will get preference. Here is ring chain isomerism and here is functional isomerism. So ring chain isomerism will get preference. And this is tautomerism. Tautomerism I will teach once you know resonance. So tautomerism will be come later on. It is going to come later on when isomerism is completed. Everyone write down. If you got it, Gopi Ganeshji, welcome. Unboxing brother. So everyone right now write down. Right is famous position. Right, famous position. Right, famous position. Right, famous position. Everyone, right is FMC. It's like FMC. AFMC. Right, AFMC position. Wow, write down your AFMC position. Oh, Army Force Medical College. Write your AFMC position. Oh, great. We got it. We made the new trick. Write your FMC position. Wow, great. Right, AFMC position. Wow, Santoshji, you got it. Everyone got it. All right, FMC position. All right, FMC position. So, ring chain isomerism is better than. Now, let me give you one more trick for it. Now, see to it. If I am having example, for example, C4H8, same compound, and if I am writing one compound like this, and another compound like this, CH2 double bond CH, CH2, CH3. Now kids, I wrote three types of compounds. One is being suppose X, Y, Z. Now could you please let me know what is the relation in between X and Y? Relation in between X and Y. Relation in between X and Y. I'm waiting for your answer, kids. What's the relation in between X and Y? Kids, do let me know what's the answer. So see, kids, everyone see to it. 1, 2, 3, 4. PC is of 4 carbon atoms. PC is of 4 carbon atoms. 1, 2, 3. PC is of 3 carbon atoms. So X and Y are chain isomers. Chain isomers. Or you can also do this compound like this, CP number. I must have told you CP number. Its CP number is coming out to be 4 and 0. 4 and 0. Its CP number is coming out 3 and 1. CP is coming out 3, 1. If the CP is changed, if the CP number is changed, that means they are chain isomers. So they are chain isomers. Now see, if I ask you another question, relation between X and Z, X and Z, fast if you are able to understand X and Z, or if I say Y and Z, Y and Z, kids, if you are able to understand, do let me know. I am waiting for your answer. If you are not going to give the correct answer, then what's the use? What is CP? CP I have told you in the lecture number 2. Meenal TUGJEE, please, you can see lecture number 2. There I have told you about CP. What is being CP? So, see, this is cyclic, that is acyclic. You see to it, everyone. This is being acyclic, not cyclic. These two are being cyclic. This is being cyclic. That is also being cyclic. So when they are cyclic and acyclic, so we'll say they are RCI as well as functional isomer. RCI as well as functional isomer. If we want to give priority, then definitely priority should be given to RCI, RCI. Is it clear? If it is clear to all of you, show me the thumbs up. If you are able to understand, then show hearts to yourself, everyone. If this is clear, done and dusted, show me the thumbs up. If you got it, if you like the explanation, always follow the rule. Hearts to yourself and thumbs up. I can say Vignesh ji, Gopi Ganesh ji, very good, Cherry Baby ji, wow, really awesome, that's really awesome. Now, after ring chain isomerism, I'm going to move towards metamerism. See to it, metamerism. I'm going to, okay, those who are unable to understand, let me give you one more example. See to it, one more example. Suppose if I'm going to draw a compound like this, everyone see to it. One compound, second compound, see. What will you say? Their molecular formula is same. How to find out the molecular formula? Are you going to draw or going to count the number of hydrogen atoms? No need to count the number of hydrogen atoms. Just see the dV and number of carbon. Here the number of carbons are kids. Number of carbons are 5 and dV is 1. Those who have not seen the lecture of dV, please, after this lecture you have to watch it. dV is 1. So definitely here number of carbons, you can see number of carbons, total number of carbons 5 and 1 cycle, so dV is 1. So the number of carbon and dV, if they are same, do remember one thing, very clear one thing. Kids, if number of carbons and dV are same, then their molecular formula will 100% be same. Molecular formula must be same. Molecular formula must be same. No need to count number of hydrogen atoms. No need to count number of hydrogen atoms. Number of hydrogen atoms must be remaining same, kids. Now see, This is cyclic, this is also cyclic. This is being cyclic, this is also being cyclic. So will you say that they are ring chain isomers? Do let me know in the chat section. Will you say they are chain isomers? They are ring chain isomers? Definitely they are not ring chain isomers, because for ring chain isomerism, one must be cyclic and another must be acyclic. So they are not ring chain isomers. So what are they? Yeah, I can see in the chat section. So just try to find out. This is the parent chain of how many carbon atoms? Here is the parent chain of 1, 2, 3, 4, 5. Parent chain is of 5 carbon atoms, and here the parent chain is just of 4 carbon atoms. So definitely they are chain isomers. In between this and this, the relation is, let me call it, this is your A and this is your B. So what is the relation in between A and B, kids? If anyone is asking, find out the relationship in between A and B. So definitely A and B will be known as chain isomers, right? Now, simultaneously, if I am going to draw one more structure, if I am writing like this, CH2 double bond CH2, 1, 2, 3, 4, 5. Now see, if I give number, this is being C. If anyone is asking what is the relationship in between A and C, do let me know, kids. What is the relationship in between A and C? A and C. Kids, if you are able to understand, give me the answer. A and C. What is the relationship in between A and C? Do let me know, everyone, if you are able to understand. Ring chain isomers. They are ring chain isomers because one is being cyclic, this is being acyclic. Acyclic means not cyclic. Not cyclic. Now, if anyone is asking B and C, definitely B and C are also going to be RCI, and all RCI are always functional isomers. So kids, if this is clear to all of you, then I'm going to move ahead. But first, do let me know. Then we are going to do number of questions. We will definitely solve number of questions. But do let me know the thumbs up, because between me and you, this is the only way of communication that everyone. RCI and functional isomers. So always, all RCI are always functional isomers. Always functional isomers. Okay. Now, after this, I'm going to tell you about metamerism. Metamerism. Very good. I can see. Very good. This is really good. Now see, metamerism. Another type of structural isomerism, the name is metamerism. Metamerism. This is really very, very important. So remember that. How to find out metamerism? If at least on one side of polyvalent, if at least on one side of polyvalent functional group alkyl group is changed. What I'm saying? Alkyl group is changed. Alkyl group is changed. Alkyl group is changed. So this is really going to be very, very important. If at least on one side of polyvalent. Now we have to understand what is this polyvalent functional group. This is going to play an important role. Polyvalent functional group. Alkyl group is changed. What is changed? Alkyl group is changed. Alkyl group is changed. So right now you won't be able to understand anything. So let me explain this metamerism with the help of one example. So everyone ready? Are you ready, everyone? Do let me know, everyone ready? So see to it. See to it. If I write down formula like this, C4H10O, C4H10O, and I'm going to draw one ether from this. I'm going to write down one ether from it. See to it. CH3, CH2, oxygen, CH2, CH3. You can see this is ether. This side also I am having ethyl group. I got ethyl group on right hand side and I got ethyl group on left hand side. Now if I write another compound, B compound, if I write methyl on this side, oxygen, CH2, CH2, CH3, do let me know their molecular formula is remaining same or not. Do let me know, is their molecular formula is remaining same or not? Yes, this was having 4 carbons, 1, 2, 3, 4. It is also having 4 carbon, 1, 2, 3, 4. But here is methyl, here is being methyl, and that side I have got N-propyl. Both side alkyl group got changed. What I said, at least on one side. If on one side alkyl group is getting changed, then also it is metamer. If both the side it is getting changed, then also it is metamer. At least means at least on one side. So kids, what is the relationship in between these two? They are metamer. Now if I am going to write down one more, see to it, everyone see to it. C1, CH3O, CH3, CH3. This is remaining methyl. This was methyl and this is also methyl, kids. That was methyl. This is also methyl. This has not got changed. But here you can see this is isopropyl. This is isopropyl. Kids, see to it, everyone. This was N-propyl because this is straight chain. Straight chain. You can see 1, 2, 3. What I'm saying? 1, 2, 3. 1, 2, 3. It was straight. N-propyl, normal propyl. But see, it is bent. It is bent. 1, 2, 3. Isopropyl. So all 3 are being metamers. Kids, are you able to find it out? Just see to it. What I can see in the chat section. Are you able to understand or not? All 3 are being metamers. So with molecular formula C4H10O, we got 3 types of metamers. What are they? Diethyl ether, methyl and propyl ether, methyl isopropyl ether. Are you able to understand, kids? Do let me know in the chat section. Everyone, are you able to understand? Kids, hey kids, show me the thumbs up. If you are able to understand it, then I can move ahead. So 1, 2, A, B and C, all these are being metamers. A, B, C, A, B and C, A, B and C, all 3 are being metamers. And kids, the special thing, let me tell you about these metamers. The most important thing I'm going to tell you about metamers. See to it. I'm going to tell you the most important thing, that is note. See to it. Note. Note is all metamers are always either chain isomers or position isomers. Do remember this thing. All metamers are always either chain isomers or position isomers. This is the most important thing which I am going to tell you, kids. Do remember this thing. This is the $1 million thing concept. all metamers are always either chain isomer or position. Let me show you. Let me show you. See to it. The example which right now I have given to you, if I write it down once again, CH3, CH2, oxygen, CH2, CH3, another example, CH3, O, CH2, CH2, CH3. Another example was CH3, O, CH2, not CH2, CH3, CH3. These three metamers I have drawn. Now see to it, kids. If I write down the parent chain is of 2 carbon atoms. PC is of 2 carbon atoms. You can see 2 carbon atoms. But here, PC is of 3 carbon atoms. 3 carbon atoms. Can you see? PC is of what? PC is of 3 carbon atoms. Can you see? So if I say, let us suppose this is your X, this is your X, this is your Y, and this being your Z. So X and Y are metamers. X and Y are metamers. Simultaneously, they are also what? Metamers as well as chain isomers. Chain isomers. Both X and Y are metamers and simultaneously they are chain isomers. Then why metamer has got the priority? Why metamer has got the priority? So you know, right? FMC position. Do you remember this? Who got more preference? Do let me know. There is metamer, and there is chain and position. Who is going to get more preference? Kids, who is going to get more preference? Metamer will always get more preference over chain and position isomer. Now let me count over here. 1, 2, 3. 1, 2, 3. 1, 2, 3. Kids, here 1, 2, 1, 2, 3. So X and Z are chain isomers. Are you getting my point? Once again, if I compare X and Z are metamer as well as chain isomers. Metamer as well as chain isomer. These were also metamer, chain isomer, but metamer is going to get more preference. But if I am going to write Y and Z, what is the relationship in between Y and Z? If you are able to understand, kids, do let me know what is the relationship in between Y and Z. See, in Y, the parent chain is of 3 carbon atom, but the position of alkoxy is 1. This is also 3 carbon atoms parent chain, but the position of alkoxy is 2. Position of alkyl group is got changed. If I write down the CP number, for this the CP number is parent chain of 3 carbon atoms and alkoxy group's position, there is 1 alkyl group, 3, 1. Now if I write down 1, 2, 3, parent chain is of 3 carbon atoms and 1 alkyl group, 3, 1. When the CP is remaining same, kids, when the CP is remaining same, what I have told you, if CP is different, then chain isomer. If CP is same, they are position isomers. So they are position isomer as well as metamer. Metamer as well as position isomer. Preference should be given to metamers. So kids, this page is clear to all of you? If yes, sir, are Y and Z not Fi, functional isomer? No, they are not functional isomer because all they are ether. All these are ether, so they are not functional isomers. All they are ether. So functional group is same, all they are ether. So functional group is remaining same. Who has asked this question? Muhammad Ahyaji, all they are being ethers, so their functional group is remaining same. Everyone got it? Are you able to understand, kids? If it is clear to all of you, do show me the signal of getting it. Kids, I want to see green signal from each and everyone if this point is clear to all of you. If you want to take, you can take screenshot, and do remember each and everything. Kids, this is really very, very important. So I can see number of thumbs up and the hearts coming from each and everyone. Yeah, definitely. That's really something awesome. So, kids, really, that is super clear to each and everyone. I can see the signal from each and everyone. And, okay, so now kids, functional isomerism is left. Once I'm going to tell you about the functional isomerism, then we can do number of questions. But before functional isomerism, let me tell you what is the meaning of polyvalent. Because over here in this definition, in the definition of metamerism, I have used one word that was polyvalent. What does it mean? What the word polyvalent mean? So please let us know when you will start. I'm unable to understand. So, see kids, one more example of metamerism. One more example of metamerism. Another example of metamerism. Another example of metamerism. Everyone try to understand. Kids, remember one thing. Do remember one thing. I'm going to write down 2 degree amine. 3 2 degree amines I'm going to write down. One is CH3, CH2, NH, CH2, CH3. Second one I am going to write down like this: CH3, NH, CH2, CH2, CH3. And the third one, let me write down the name of this: X, this is your Y, and this is your Z. CH3, NH, CH, CH3, CH3. Kids, how to find out whether they are metamers or not? So do remember, first of all, we have to check whether they are functional isomer or not. If the functional group is same, then only we have to see. So see how to find out what is the degree. You can see this nitrogen. This nitrogen is attached with how many alkyl groups? One alkyl group and one alkyl group. So the degree of this amine is 2 degree amine. 2 degree amine. If the amine's degree is getting changed, then they will become functional isomers. So functional group should remain same. This is 2 degree amine. Now this nitrogen is also attached with 2 alkyl group. One alkyl group, second alkyl group. So its degree is also 2 degree. This is also 2 degree amine. Now, if I talk about this last one, you can see to it, this nitrogen is attached with 2 alkyl groups. Can you see? One alkyl group, another alkyl group. So this is also 2 degree amine. Once the functional group is same, all they are 2 degree amine. All three are 2 degree amines. That means what? That means their functional group is same. That means functional group is same. Now, once the functional group is same, we can talk about metamerism. Now, just check it out. This side we have got ethyl. Over here we have got ethyl. Both the side we have got ethyl, kids. Now, in this, you can see here we have got methyl, and that side we have got N-propyl. N-propyl kids, N-propyl. Can you see? And in this we have got methyl, and that side we have got isopropyl, isopropyl kids. Can you see? So all three are being metamers. All three are being metamers. Is it clear to all of you? Functional group is same, so all three are being metamers. All three are metamers. So I think this metamerism is clear to all of you. Now, only one thing is left, kids. Only one thing is left. What does the polyvalent functional group means? Because if you don't know the meaning of polyvalent functional group, you won't be able to do any question. See, let me write down this side polyvalent functional group and that side monovalent. See, let me write down this side polyvalent, which can show metamerism. This is polyvalent, can show, may show metamerism. But this side I am going to write monovalent functional groups will never show metamerism, will never show metamerism. See to it, kids. This is really very, very important. Now see, if I am going to write down ether, as I have told you, ether is R-O-R, two sides. Now if I am going to write alcohol, R-O-H, only one side, its valency is free. This can be changed. This will always be remaining as OH. So this side we cannot write anything. So this will never show, ether may show. Now if I am going to write secondary amine, NHR, R dash can be same or different, but I am going to write RNH2, 1 degree amine, 1 degree amine. So it can never show because it is having only one side valency, second side 2 hydrogens should be there. It will never show metamerism. Kids, mono will never show. Now see, if I am going to write S2, if I am going to write S2, RC double bond O, OR dash, you can see this side, but I am going to write acid, RC double bond O, OH, monovalent. It will never show your metamerism. Are you getting my point? Now if I am going to write, kids, your RSR will show, may show. If I write RSH, will never show. I think you are able to understand, kids, what the meaning of monovalent and what is the meaning of polyvalent. Kids, do let me know. Let's have some fun. That, kids, do let me know. I'm going to give you one question. Are you ready? On basis of this, I'm going to frame out one question. See to it, kids. Question is, which compound can't show metamerism? So the question will come like this. Then I will give you the printed questions also. Wait for that. For printed questions, for MCQs, we should have enough knowledge. Once I'm going to give you the knowledge, and then we can deal with the questions. Stay tuned, right? Stay tuned and call your friends. Kids, what is this? Everyone, I think you're not feeling that Josh. Where's the Josh? I can't see the Josh. Yeah, Vignesh ji, ketones can also show. Yeah, ketones are divalent. They can show. Amides can show. Now, etc. There was etc. Number of, so it's like etc. Number are there. Number of compounds are there. Vignesh ji, number of compounds are there. Now see, kids. First one is your C2H5 NH C2H5. B is CH3 CO NH CH2 CH3. C is CH3 CH2 C double bond O CH2 CH3. Now D is CH3 CH2 CH2 COOH. Now what's your answer? Kids, everyone, fast, be quick. Okay, Shamli, Vishali ji, Kamla is okay. Let me check it out. Now let me focus it. Don't worry. Zoom, 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 zoom. Now check it out. Shamli ji, now just check it out. Is it okay? D is the correct answer. Yeah, D is absolutely the correct answer because this is bivalent, bivalent, this is monovalent, this is being monovalent, and monovalent can never show the metamerism. All they are bivalent, but this is being monovalent. Thank you. Okay, now kids, once this is clear, let me give you one more question. Fantastic, awesome question, frequently asked question. See to it. If I'm giving you one question that C4H10O will have how many metamers? Will show how many metamers? Kids, do let me know the answer to this question. Let me check it out. Metamers. This is your question. Options are A is 10, B is 6, C is 3, D is 20. So let me know what's your answer. Kids, what's your answer? Everyone, do let me know what's your answer. Kids, I'm waiting for your answer. 3, yeah. Aruna Kumari ji, it's not 2, it's 3. I have explained it. The answer is 3. Answer is 3. How 3? I've told you CH3, CH2, O, CH2, CH3, 1, CH3, O, CH2, CH2, CH3, 2, CH3, O, CH, CH3, CH3. So all total 3. These were 3. Is it clear to all of you? Able to understand? Do let me know. Everyone, if this answer is clear, you are able to understand, show me thumbs up. Everyone, show me thumbs up. Ritvik Singh Parihar, Shanti Visali ji, Unboxing Brothers. After a very long time, I can see you. Very long time, no see. Kids, everyone. Okay, now this is clear to all of you. Metamerism is clear. Now let's deal with functional isomerism and then we will do number of questions. Kids, now see to it. Everyone, functional isomerism. I'm going to deal with functional isomerism. This is really very important. Functional isomerism. Compounds having same molecular formula. Compounds having same molecular formula but different functional groups. Now kids, this is very easy, but let me tell you the most important thing. If you don't know that thing, your answer may get wrong. It's really very, very simple, but those concepts which I'm going to tell you, if you don't understand those concepts, you won't be able to do the questions. So see to it, everyone. No trick for that. Santosh ji, just do remember for that, there are 3. If we are taking 4 carbons, your answer is going to be for ether as well as for amine, the answer will be 3. Do remember that example, then you can solve any question. Okay, Santosh ji? Now see, everyone, let me tell you about this. Suppose if I am going to take one organic compound like this is known as phenol over here, and this methyl, so I will say metacresol. Cresol, it is known as when methyl and OH is there, cresol, and this is meta position. So I will say metacresol, this is the name for this compound. And if I'm going to write another compound like this, see kids, this CH2OH, what will you say? Are they functional isomer? Are they functional isomer? What you will say, A and B are functional isomer? Then definitely what you are supposed to see, just think about their molecular formula. Their molecular formula is exactly same, and this OH is attached with sp2 hybridized carbon, and that OH is attached with sp3 hybridized carbon. So kids, do remember, if OH is attached with sp3 hybridized carbon, it is going to be basic. It is going to be basic. So this is known as alcohol. Its name is benzyl alcohol. Benzyl alcohol. Its name is benzyl alcohol because it is attached with sp3 hybridized carbon. And this is phenol. This is being phenol. Phenol is acidic in nature. Acidic in nature. And alcohol is being basic in nature. Basic. So remember that alcohol and phenol, they are functional isomer, because this mistake is most often done by most of the students. You never have to do. You are not supposed to repeat this mistake. So kids, first of all, I would like to say on the first number, phenol and alcohol, they are functional isomers. Now today you will see the use of DVE over here. Second one, I can say ether and alcohol. Ether and alcohol are always functional isomer. See, when the example is like this, I am going to take CH3O, CH3, and if I take CH3, CH2OH, you can see their physical and chemical properties are different. There is lot of difference in the boiling point. See, hydrogen bonding due to intermolecular hydrogen bonding, hydrogen bonding, its boiling point is high, its BP is high, BP is boiling point is high. Its ether, its boiling point is down because no hydrogen bonding, it is volatile liquid, that is high volatile. This is less volatile and having high BP. Now this compound is having acidic hydrogen, so their chemical and physical properties are different, and once the chemical and physical properties are different, physical and chemical properties are different, so they are, yes, having same molecular formula and physical chemical properties, at least one property is found to be different, then we'll say they are, yes, isomers. Now see to it on third number I am going to tell you kids. If I write down carboxylic acid, just try to find out with your brain, carboxylic acid. No need to cram, kids, no need to cram. Carboxylic acid. If I write down hydroxyaldehyde, And if I write down, hydroxyketone, and if I write down ester, they all can act as functional isomer. Now kids, you must be thinking about, sir, you are the sir, we are kids, very small kids, how to find out? See, use DB, you can become even more intelligent than me. Just keep in your brain about DB. See everyone, Vignesh, what I am writing, is this not YouTube? Not able to understand. Now see, I am going to write down some structures. Now see, carboxylic acid. If I am writing like this, CH3, CH2, CH2, COOH, just focus on the DB. It will become miraculous. You will be able to understand. So what I have considered, 4 carbon atoms and DB is 1. Just keep in your brain, where we have to focus? DB is 1 and carbons are 4. Just forget about the number of hydrogen atoms. Just keep in your brain what I am saying, kids. DBE is 1 and 4 carbons. Just keep it in your brain this much. If you are able to keep this thing in your brain, you can write down anything. See to it. How many carbons I have to keep in my brain? 4 carbon. 1, 2, 3, 4. Hydroxy. Let me place hydroxy. Aldehyde. Let me write down aldehyde. Now see the magic. Everyone see the magic. If I am going to write down the hydrogens by themselves, they will get balanced. See to it. See the magic of DB. Everyone see the magic of DB. Hydrogens must be balanced. 1 valency is there, CH3. 3 valency is there, 1 hydrogen. 2 valencies are there, 2 hydrogen. 4, already 4. So just check it out. 3 hydrogen, 3 plus 1, 4. 4 plus 2, 6. And 1, 7 and 1, 8. So this was also having C. All they will have same molecular formula. C, 3, 2, 5, 2, 7, 1, 8. C4, H8O. This is also having C4, H8O. So what do you say? This was carboxylic acid and this is hydroxyaldehyde. Their functional group got changed, so they are functional isomer. Now let's see hydroxyketone. 1, 2, 3, 4. Let me draw it. Ketone and hydroxy. Let me write down hydroxy. Now see the number of hydrogens, they must be balanced. CH3, CH2 and CH2OH. Balanced. Now ester, carbon, 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 double bond O, CH3. Now see, what I am keeping in my brain, that carbons must be 4, oxygen is 2, oxygen must remain 2, 4 carbons, 2 oxygen, 1 dB, I can draw anything. Yeah, O2, it's O2. I wrote by chance O, it's O2, kids. You're right, definitely it is O2. Oxygens are 2, kids. So, see to it, if I write 3 hydrogens, 2 hydrogens, and it is balanced. So, all they are being what? All they are being functional isomers. Can you see, kids? Kids, can you see? It is easy or not? It has become easy or not, kids? I think you got tired. I think everyone got tired. Kids, what is this? You are not able to answer. Now, kids, let me see. Once I am going to tell you, then we will solve number of questions after this. Now see to it. Everyone see to it. Let me write down the fourth one. Fourth one, see to it. Show me some energy level. 1 degree, 2 degree, and 3 degree amines. They are functional isomers. Fifth is 1 degree, 2 degree, and 3 degree amides. 3 degree amides, they are also functional isomers. Now, urea and isourea, urea and isourea, they are also functional isomers. All ring chain isomers, all ring chain isomers are functional isomers. All tautomers, tautomers I will teach you after resonance. All tautomers are functional isomers, and this we will cover after resonance. We will study after resonance, otherwise we won't be able to understand. After resonance, we will study, we will see to it. After resonance, otherwise we won't be able to understand it. So all they are being functional isomers. 1 degree, 2 degree, 3 degree amines, they are functional isomers. Amides, they are being functional isomer. Now see kids, on ninth number, cyanide and isocyanide. Cyanide and isocyanide, they will be functional isomers. See to it. If I write down CH3, CH2, CN, cyanide, and CH3, CH2, and NC, they will be known as coordinate bond functional isomers. 10th, alkyne, alkyne and alkadiene, alkadiene. For example, you see, this is alkyne, and if I am writing CH2 double bond CH, CH double bond CH2, they are functional isomers. See kids, everyone able to understand. Now we are going to deal with question. We are going to deal with question C. This is question. Everyone has to participate in this quiz. Okay? Kids, show me the thumbs up. Just I am going to take 10 minutes for the questions. Then our structural isomerism is going to get completed on next lecture. We are going to start from the next lecture, geometrical isomerism, that is stereoisomerism. Everyone, show me what's the answer. The compound having molecular formula C4H10O. So everyone, I can see your answer is going to be correct. All of these. See why? C4H10 metamerism, so we know very well that they are going to show metamerism. This so we know very well. O CH2 CH3. This is famous example. That's why I have told you I have considered CH3O CH2 CH2 CH3. Now see, functional isomerism. This is ether. Along with ether, it can be alcohol. This also I have told you, ether and alcohols, they can act as functional isomers. Position isomers, see to it. I can show you how they can behave as position isomer. OH, CH2, CH3. Here is the position. Second position. On second position, OH is there. Now I can draw another compound, CH2, OH, CH2, CH2, CH3. So what is the position at this in this compound? 1, 2, 3, 4. First position. So all of these is the correct answer. Now another question, kids. All of these. This is the correct answer. Another question. The total number of structural isomers is possible for C5H11Cl. Kids, do let me know. This is your favorite question. Already I have explained that this is frequently asked question. Frequently asked question. Do let me know. What's your answer, kids? 8. Yes. Mohana Aruna Kumari ji, 8. 8 is that second. 8 is the correct answer. So everyone's answer is correct. Now, an alkane can form a structural isomer if the number of carbon atom is. This also I have told you, kids. Homework question I will tell you. Definitely I will let you know. But first of all, do let me know what is the answer of this question. Kids, do let me know. I want to see what's the answer. 4. To show structural isomerism is equal to or greater than 4. This is the correct answer. Kids, really, you are awesome. Your study is up to mark, I can see, and those who are working hard, definitely their success is waiting. Now, C4, this is, I think, this is the question given by me. This was the question given by me, right? I think this was the question given by me, and this is the most important question. Most important question for your NEET examination. This is in demand, kids. This is in demand. This is the most important question, and I will explain this question. See, kids, most of the students, they are writing D or 3. Let me check it out. What should be the answer, kids? What should be the answer? So, let me explain it. See, C4, H11N. If I want to write down primary amine, if I'm going to consider for primary amine, 1 degree amine, if I'm going to consider for 1 degree amine, what I will say, kids, for 1 degree amine, I will write it down like this: C4, H9 and NH2. Is it okay? Because if I'm writing NH2, this will become 1 degree amine. Is it fine? Now, I am having 4 carbons. I have told you the metamers with this possible. How many metamers I've shown you, kids? CH3, CH2. If you remember, your work is going to become very easy. CH2, CH3. If you remember, kids, how many metamers I've told you with, this is 1 degree amine. 1 degree amine. 1 degree. Wait. This I am going to, what? This I was writing for 2 degree amine. 1 degree amine. See, kids, for 1 degree amine, C4H9. C4H9, how many monovalent radical it forms? C4H9, it cannot form metamerism. It cannot show metamerism. C4H9 shows how many monovalent radicals? Kids, how many monovalent radicals? Number of monovalent radicals. Do let me know. Do let me know, everyone, that the answer was 4. 4. Do you remember 4? Monovalent radicals, 4. Kids, 4 monovalent radicals. So, primary amines answer must be 4. Do you remember? This I have told you, kids. Do let me know first of all that C4H9 forms 4 monovalent radicals. This I have told you, not 4 monovalent radicals. Do you remember? Do you remember, kids? Do let me know. Do you remember this thing? Kids, do you remember this thing? It will form 4 1 degree amine. Let me write down those 4 1 degree amines. Otherwise, you won't be able to understand. CH3, CH2, 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 NH2, 1. CH3, CH2, CHNH2, CH3, 2. Now, CH3, CH, CH2, NH2, CH3, 3. Now, CH3, C, NH2, CH3, CH3. So, these are all our wing 1 degree amine. Can you see? Because NH2 is there, NH2 is there, NH2 is there. That means nitrogen is attached only with 1 carbon. If nitrogen is found to be attached only with 1 carbon, that means that is going to be 1 degree amine. Now let me write down 2 degree amine. How many 2 degree amine it is going to form? So here we have got 4, 1 degree amine we have got 4. Now let me write down 2 degree amines. 2 degree amines. Kids, do let me know how many 2 degree amines are possible. So for that, I will take NH. NH. After taking NH, how much is left? How much is left? It was C4H11N. And if I have taken NH, so how much is left? C4H10. Now you remember, this is going to form 3 metamers. This will form C4H9 for 1 degree. Kids, that was for 1 degree. Total C4, what happened to the zoom focus? Now the focus is clear, kids. C4H11N, we can form 3 types of amines. Primary amine, secondary amine, tertiary amine. Vignesh ji, are you able to understand? With C4H11, I can form 3 types of amines. 1 degree, 2 degree and 3 degree. Yeah, if we are taught, this is amine. If I take butyl, they were only chlorine, that's why only 4. Vignesh ji, there we have placed chlorine, bromine, amine, that's why only 4 was the correct answer. But here amine is there, and along with C4, there are 2 extra hydrogens are there. That's why we have to apply brain. Now see. Now kids, that's why this question is really awesome. CH3, CH2, O, no, it's not O, it's N, H, CH2, CH3, CH3, NH, CH2, CH2, CH3 and CH3, NH, CH, CH3, CH3. These are 3 metamers. You can see total 3 metamers. Now kids, if I want to draw 3 degree amine, what I am supposed to do? For 3 degree amine, what I am supposed to do, kids? For 3 degree amine, 3 degree amine, I can make only 1 3 degree amine, not more than 1. See, nitrogen, I will write methyl, and what is left? CH2, CH3, only 1. So just count it, just count 3 plus 1, 4 and 4. How much it is coming? Kids, do let me know how much it is coming. 4 plus 3 plus 1. How much it is coming total? 8. It is coming 8. Total 8 structural isomers. So what I am going to write? Total, so this compound can form total 8 structural isomers. What is the answer? C4H11N will have total 8 structural isomers. So kids, you must have seen they were position isomer, because all metamers are either chain isomers or position isomers. All metamers are always either chain or position. So position, metamer, and 1 degree, 2 degree and 3 degree amines, they are what? They are what, kids? They are functional isomers. Functional isomers. This already I have told you, they are functional isomers. Kids, another question. If you are able to understand, if this is done and dusted, do let me know in the chat section with the help of thumbs up, kids. If this question is clear to all of you, do let me know, everyone. Do let me know, everyone. If this question is clear to all of you, do let me know, everyone. I'm waiting for your answer. 1 degree, 2 degree and 3 degree means 1 degree, 2 degree and 3 degree means they are being different functional isomers. Do let me know in the chat section once it is clear to all of you. I want to see the answer in the chat section, the reflection, and yes. Now, functional isomerism is not possible for out of these four, which cannot show functional isomerism. Kids, yeah, you will get, yes, we will let you know. We will let you know each and everything for the Avengers batch. Don't worry for that, kids. We will let you know each and everything for the Avengers batch. I'm asking the question, alkyl halide, yes, they can never show the functional isomerism because they have to attach like halogen. Now, another question. Wow, such a great question. The type of structural isomerism shown by given compound. This is sulfur. I want to see the answer in the chat section. What answer you're going to show? Kids, just hit the like buttons if till now you haven't gone through that. Everyone, once hit the like buttons. I want to see likes to get increased, kids. Very less likes. It shows that you don't love your HSP Baba. Kids, I want to see like buttons number should get increased. 2. Everyone is writing 2. So let me check it out whether the answer 2 is right or wrong. So 1, 2, 3. Parent chain is of 3 carbon atoms. PC is of 3 carbon atoms. And here 1, 2, 3. PC is of 3 carbon atoms. So here the position of this is 1. Position is 1 and here the position is 2. So they are position isomers. Position isomer. Although one thing is there, if in the option metamerism was given, by chance they haven't given in the option metamer. If metamerism is given, then they are metamers also. They are metamers, but in the option metamers is absent, that's why they are metamers. Even you can solve this question through the CS number. If we count the CS number, here the CS number is going to come out to be 3 and 1, 3, 1, and here the CS number is 3, 1. So CS number is same. Once the CS number is same, those who have not gone through the CS number, those who don't know about the CS number, you can see the previous lecture before the double bond equivalent, the lecture number 2 of structural isomerism. There I taught about the CS number, you can see. So metamerism, if metamerism is given, then this should be the answer, but they haven't given metamerism, that's why that is the answer. Now see another question. The pair that represent chain isomerism. So for that we should know their names. So let me help you. Propyl alcohol, isopropyl alcohol. This is being propyl alcohol, CH3, CH2, CH2OH. This is propyl alcohol, and this is your isopropyl alcohol, CH3, CHOH, CH3. This is isopropyl alcohol. 2-methylbutane and neopentane. 2-methylbutane, 1, 2, 3, 4. 2-methylbutane and neopentane. CH3, 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 CH3. This is being neopentane. Diethyl ether and dipropyl ether. Diethyl ether, diethyl ether and dipropyl ether. So I have written all these structures for you kids. Now let me see what your answer. What answer you are going to give? Muhammad Ayaji 4 and 132. The pair that represent chain isomerism. Chain isomerism. Kids, let me check it out whether your answer is right or wrong. Now let me see to it. 1, 2, 1, 2. The PC is of 2. This can't be the answer. Now see over here. 1, 2, 3, and in this, if I say 1, 2, 3, this can't be answer, this can't be answer. Now, if here I can see 1, 2, 3, 4, 1, 2, 3, and they are having same number of carbons. So this is going to be answer. This is going to be answer, and they are not the isomers. They are not the isomer because here 4 carbons and here 6 carbons. They are not isomers. They are not isomers. Not isomers. They are not isomers. So I think third is the correct answer. The pair that represents chain isomer. The fourth one, they are not the isomers. So third is the correct answer, kids. Third is being the correct answer. Let me check it out. Yeah, that's really awesome. Are you enjoying it? First, do let me know. Just 3 or 4 minutes are left. We will deal with all the questions. All the questions will be done and dusted. But do let me know in the chat section. Are you enjoying it? Are you able to understand it? So another question. So this question is a little bit. This question is little bit lengthy. So try it out and answer. Write down the answer. What answer you are going to get? Unboxing brother. Very good. Everyone, just do let me know what answer. The pair that represent chain isomerism. Now let me find it out. Chain isomerism. 1, 2, 3. Parent chain of 3 carbon atoms. 1, 2, 3. Even their functional group is changed. 1, 2, 3 carbon, 4 carbon. 1, 2, 3, 4. They are functional isomers. They are what? They are not chain isomers. They are functional isomers. So they are functional isomer. They can't be the answer. Now here in this, what I can see, kids. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. They are position isomers. This can't be the answer because they are being position isomers. Position isomer. Now 1, 2, 3, 4. 1, 2, 3, 4, 5. Yes, they are isomer and they are chain isomers. So this is going to be the correct answer. 1, 2, 3, 4. 1, 2, 3, 4. They are position isomers. Position isomers. So this can't be the answer. So the answer is definitely the third one. Kids, what you got? C. Oh my God, I can see your answer is also correct. That's really awesome. Kids, really awesome. Mind-blowing. Mind-blowing. So I think you are able to understand the concept of isomerism. Everyone, I can see you can understand. You must, one more question. The pair among the following that does not contain position isomerism does not contain. Kids, focus over here. They are not saying contain. They are talking about does not contain. So we have to talk about that does not contain. So let me check it out. If I say over here, this is 1, 2, and 1, 2. This can't be the answer. Oh, does not contain position isomerism. Wait. Position isomerism. Here the position of OH is 1. Here also 1. Position of chlorine is 2. Chlorine is 1. The position of chlorine here is 1 and here is 2. So they are position isomers. They are position isomers. So this can't be the answer. Now see over here. 1, 2, 3. 1, 2, 3. The position of NH2 over here is 1 and in this 2. They are position isomers. Now in this 1, 2, 3, 4. 1, 2, 3, 4. The position of double bond is 1 and here it is 2. So they are position isomer. Only 1 is left. What is happening? Now 1, 2, 3, 4, 5. Now 1, 2, 3, 4, 5. It is getting a little bit tough. So let me check it out. Just apply CS rule. CS number. then we can find out the answer. Its parent chain is of 5 and no substituent, so 0, 50. CS number is 50 kids. Are you able to understand? Here is one alkyl group and 4 and 1, 41. The CS number is 41. Once the CS number is changed, they are chain isomer. Because the CS number is different, so they are what? Chain isomers. I hope this point is clear to all of you. So this is going to be our answer. Agreed? Everyone agreed? Agreed, everyone? So CS number is the hero. And we should know CS number. CS number is the hero. If you have not seen that lecture, you must watch that lecture. Kids, enjoying it, CS number is working. So it's really become super duper easy because of the CS number. Kids, another question. The number of chain isomers. Oh my God. Chain isomer. This is going to be a really tough question, lengthy question. This is going to be a little bit lengthy. For C5H12, we know very well. C5H12 has how many? C5H12 has 3 chain isomers. 3 chain isomers. This is having 3 chain isomers. This though we know very well. So the answer should start from 3. This can't be the answer. And if it is 3, that should be more than 3. Kids, just apply logic. If this is 3, that should be more than 3. So see, answer should, it's only 3. See what logic we were applying. If this is 3, this should be more than 3. Let me check it out for C6H14. Kids, see to it. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and CH3. The parent chain in the above one is parent chain is of 5 carbon atoms. Here the parent chain is of 4 carbon atoms. Now what I can say, 1, 1, 1, 1, 1, 2, 3, 4, 5 and 6, 5 and 6. Now there the parent chain is of 4 carbon atoms. Parent chain is of 4 carbon atoms. 1, 2, 3, 4, 5, 6. There the parent chain is of 6 carbon. Sorry. Here the parent chain was of 6 carbon, 4 carbon, 6 carbons, 5 carbons and 4 carbons. Is it possible to draw parent chain of 3 carbons? Kids, do let me know. Is it possible to draw parent chain of 3 carbons? Let us try to draw parent chain of 3 carbon atoms. Let me try. 1, 2, 3. Now if I am going to write ethyl over here and methyl over here. See kids, now the parent chain is of 3 carbon or 4 carbon atoms. Just to let me know. Here the parent chain is of 3 carbon atoms or 4 carbon atoms. I think this will go like this, 1, 2, 3, 4. And this compound is same, this and this, they are same. Oh, great. See kids, this is a really awesome question. We cannot draw parent chain of 3 carbon atoms. So this is a really awesome question. Brilliant question. I would like to say this is a really brilliant question. Brilliant question. Definitely, most of the students are going to get negative marks over here. You like this question? Did you like this question, kids? Did you like this question? Now, a functional isomer of 1-butene is like this. 1-butene is like this. So I must have told you it's functional isomer. In my notes, I have told you that what is the functional isomer? See to it, kids. If I write 2-butene, 2-butene will be pi of that, position isomer of that. 1-butene can't be the functional, not the isomer, not isomer, it's not the isomer. 2-butene, It's not the isomer, not the isomer, not isomer, not isomer. So see kids, 1,3-butadiene, 1,3-butadiene. See kids, 1,3-butadiene. Yes, this is the answer. Alkyne and alkadiene. Alkyne and alkadiene are functional isomers. Alkyne and alkadiene. Let me show you this. I've told you or not. So this is going to be the answer. Let me check it out whether this thing I've told you or not. When I was telling you the functional isomerism, kids, functional isomerism, when I was telling you the functional isomerism, see kids, this I have explained or not, alkyne and alkadiene. See kids, this I have explained or not, do let me know kids. And the same example I have given you, kids, can you see kids, same example I have given you. Now on which slide we were? So we were on this slide. So this is the correct answer. You got it. I think you are able to understand. Yeah, definitely. So another question, methoxyethane and propanol are. Methoxyethane क्या होता है बेटा? Let me check it out. Methoxyethane. So this is your ethane. This is your methoxy. So this is your methoxyethane and propanol. CH3, CH2, CH2OH. So they are having same carbon. Their molecular formula is definitely same. Its molecular formula is same. Just see to it. C3. Their molecular formula is C3, H325 and 8, C3H8O. So they are isomer. This is being ether. This is being ether. And this is being alcohol. So what answer you're going to get? They are being functional isomers. C is the correct answer. Very good. I can see in the chat section that everyone wrote C. Very good. So this was all about today's session. So kids, I'm going to give you one question for your homework. And I want to see the likes. Kids, likes are very less. Am I not teaching good? My teaching is not good. My teaching is good or not? If it is good, I won't see the likes. They should get increased, kids. Now, today's question of the day. Question is, find out DBE. Find out DBE. Find out DBE. And DBE of what? DBE of this compound. DBE of this compound. This compound is very well-known compound, cubane. This is known as cubane. And you're supposed to find out DBE of this compound. Okay? The best. Thank you, Muhammad IITJEE. Thank you. And you are supposed to find out DBE of this compound. And you must have seen that always I used to give answer in the chat box. So once this video is over, you are supposed to write down the answer of this question. Bye to all of you. We'll meet you in next session. That is the best session of GI, geometrical isomerism. So that is really very, very important. Don't forget to come same time, that is 11 a.m. Okay? Bye to all of you. What is DB? If you have not seen the lecture before this lecture, educational system, DB, there was one session named as DBE, because that session is going to increase your speed for isomerism and to see the organic chemistry. That session's name is DBE. Okay, it's written over there. Watch yesterday. Yeah, Vignesh ji, yes, you can say you have to watch yesterday's class. Simple thing, simple. Yes, Vignesh ji, really good. Bye to all of you. We'll meet you in another session, that is of geometrical isomerism, 3D isomerism, space isomerism. Bye to all of you.